All right, let's talk about something huge for anyone building on the web. How do you actually build an application that can handle a massive, unexpected crowd? Today, we're going to break down a foundational AWS architecture that solves this exact problem. So, picture this. You launch your new website, your new app. It's kind of quiet at first, and then boom, a celebrity tweets about it, or you hit the front page of a big news site. All of a sudden, thousands, maybe even millions of people are all trying to get to your site at the exact same time. What happens? Well, for a lot of traditional setups, the answer is pretty simple and painful. It crashes. See, a single server is like a small coffee shop with just one barista. If a tour bus with 100 people pulls up, that barista is going to get completely overwhelmed. The line grinds to a halt, and nobody gets their coffee. And that is the exact problem we are going to solve today. So how do we fix this? Well, instead of one overwhelmed server, we're going to build a smart, flexible system using Amazon Web Services, AWS. And it all starts with one really fundamental building block. That first block is called EC2. It stands for Elastic Compute Cloud. And to put it simply, it's a service that lets you rent virtual computers in the cloud. You should think of an EC2 instance as the engine for your application. It's the place where your code is actually going to run. Okay, so this is where our journey starts. We have a single EC2 instance, this is our virtual server, and it's all ready to run our code. But an engine is pretty useless without the rest of the car. To build a complete application, we're going to need a few more key pieces. Up next, every app needs to store things, right? We're talking user images, videos, documents, you name it. And it's really not efficient or scalable to just cram all of that onto our one EC2 instance. We need a dedicated, separate place just for storage. And that's where S3 comes in, Simple Storage Service. S3 is designed to do one thing and do it incredibly well: store and retrieve data. You can honestly just think of it as a massive, infinitely large digital filing cabinet up in the cloud, and it's totally separate from your compute engine. So here's our new foundation. We've got our EC2 instance for all the compute power, and it's connected to S3 for data storage. Now, separating these two is absolutely crucial for flexibility. But we still have our original problem. What happens when that big traffic spike hits? Yeah, exactly. This setup is still vulnerable. One EC2 instance is still just one virtual server. It is going to get overwhelmed. So how do you handle a crowd when one server just isn't going to cut it? The solution here is really pretty elegant. We need something that can stand in front of all of our servers and just intelligently direct all the incoming traffic. What we need is a smart traffic cop for the cloud. And here it is, the Elastic Load Balancer, or ELB. Its job is pretty much exactly what it sounds like. It takes all the incoming requests from all your users, and it distributes them evenly across a whole fleet of EC2 instances. This makes sure that no single server ever gets overwhelmed. And here it is, the full picture. See, users don't connect directly to an individual server anymore. Nope, they connect to the load balancer. The ELB then acts as this single front door, routing traffic to a whole group of identical EC2 instances. And all of those instances can then access the same shared data in our S3 bucket. So we've built this really slick piece of architecture. But what did we actually get out of it? Well, we get two massive benefits that directly solve our original problem: dynamic scalability and incredible resilience. Okay, first up, scalability. And this isn't just about having multiple servers. It's about having the ability to automatically add more servers when traffic is high and, just as important, get rid of them when traffic is low, so you only pay for the capacity you're actually using. That right there is elasticity in action. So how does this work in the real world? Well, when traffic spikes, the load balancer detects that increased demand. Then, a service called autoscaling automatically launches a brand new EC2 instance and adds it to the group. Immediately, the load balancer starts sending traffic to this new server, sharing the load, and it all just happens in moments without any human having to lift a finger. The second big payoff is fault tolerance, or you could call it resilience. So what happens if one of our EC2 instances has a problem and just fails? Well, in the old single server world, your website would just be offline. But here, the load balancer is smart enough to see that an instance is unhealthy. It just stops sending traffic to it and reroutes everything to the remaining healthy ones. For the user, absolutely nothing changes. The site just stays online. This slide really just puts it all into perspective, doesn't it? We went from this fragile, single server setup that had one point of failure to this robust, distributed architecture. We've totally eliminated the single point of failure. We can scale to handle practically any amount of traffic. And we've built a system that's incredibly reliable and always available. So the key takeaway is this. By combining just a few core AWS services, we created a really powerful and foundational pattern for the modern web. We separated our compute with EC2 from our storage with S3. And then we put a smart traffic cop, the ELB, right in front to manage the flow. And the result is a system that can both scale up on demand and tolerate failures without ever missing a beat. And that really leaves us with a final thought to chew on. When you no longer have to worry about forecasting your traffic, or what happens if a server dies, when you can build systems that just automatically adapt to whatever demand is thrown at them, how does that change the speed at which you can build and test and deploy new ideas? It's a fundamental shift in what's even possible.